Next standard is 100. So Dustin have put it 100. So disconnect by division 16. Division 26, guys, is the electrical. Always say electrical, division 26. What's the size? 100. Any question about the division and the size? Any question about the division and the size? Division 16 means the electrical contractor is responsible for doing it. I mean, do it. Division 26. 26 is a new format for CSI. All right. Now let's look at the type. The type, now Dustin is saying non-fuse, but Dustin, what did they say down here? They say a fuse. So what do? You're going to, very easy, you come over here and you get rid of the oops, you're going to say fused. That's it. Okay, now disconnect type fused, disconnect location outside mechanical room. Thank you. Because why? Because it says outside the mechanical adjacent, fuse disconnect adjacent to the equipment. The equipment is outside the mechanical room. It's going to be outside the mechanical room. Any questions about this? That's straightforward. Okay, let's continue with the following. Okay, now starter by starter size. Let's continue reading about this one. It says provide 16 to provide fuse disconnect adjacent to the unit. Did they say anything about starter? Did they say VFD, NEMA? All what they need is a disconnect. And then in a case like this, I would click this one and say starter by division 27. 27 are the mechanical guys. And starter size, I care less. So leave it blank. Did you see why I left this one? 27 is a mechanical. I think it's a mechanical. 27. And why did you leave it blank? Because they're going to do it. I'm not going to do it. Right? Where's the format? 26, 28. I thought 26, 27. Or no, 27 is not them. What the heck do they become now? I don't know what they become. No, not 27 is not them. I have to look at, I'll give you that number, guys. Just leave it 27 now until I give you the right number. There's a new number for them now. What the heck did I give you? I have the electrical numbers, but not the mechanical numbers. All right. Okay. Can you just do it for the time being, put division 17, guys? Because I don't know the new division for you. If it's mechanical, just put division 17 until I get you the new one. Okay, now let's go back to the starter type. If we're not providing the starter, I have no idea what the starter is. So just dash it. Where the starter is going to be located. Also, we're not providing it. So do we know? Probably we can, but just dash it. Okay, make sure. If we don't provide the starter, don't worry, just blank the rest of them. We're not providing it. None of our business. This will be filled by our cousins, the mechanical engineers. Okay, let's go back all the way to, any questions about this? Controller by, I say 27 here. I know it's wrong right now. I'm going to make it 17, division 17. Actually, even division 17 is 7. What the heck is that division? Where is that?
It said 27.
Yeah, I know, but it's wrong. 27 is communication, actually. I was wrong. There is a division for them, but I can't remember what the division for them is. The heck did they go? CSI specification. I can't remember where they are. Standards, specification, CSI tech homepage. I have a copy of it, I don't have it on me. This is not what I'm looking for. Standards. think I have it under standards too. And see, of course, when you want something, it's not going to be here, huh? Okay, anybody can research the CSI? There's a lot of CSI. If I spelled it right. Specification. Okay. I'm not finding it. Okay, I'll get it to you. Let's just continue with what we're doing. This is not a big deal, guys, at this point. Okay, so if I get you to do me one little favor, wherever we put 17, can you guys put 15 just to continue with the old specification here? Just go to 15 for now until I get you the right number for them. 15, I know for a fact, these are the old version of it. 15. Okay, we're not providing it. All right, so let's continue. Conduit size. I have PVC. These are outdoor, guys. So it's 3 conductors, PVC, schedule 80. The full load amp, that when the size, remember the full load amp for this? Let's go size it right away. Full load amp for this one, guys, was I'm gonna size based on 91 amps. Why 91 amps? Because it's chiller from right here, 91 amps. So let's go size for 91 amps and see what we come up with. 91 amps. 81 amps. You're going to size based on 91 amps. The one that says minimum circuit ampacity, MCA, always. Okay. Minimum circuit ampacity, 91 amps. Okay, everybody got the 91 amps, guys? Please. Let's go to the calculator quick here and see if we can get that baby fired. All right, so let's go change this one to set 75. I'm going copper 75, and I have 91 amps, and I need a conductor size, wire size. That's it. Oops. 91 amps, right? And I need wire size. Number 3 cover. How did you come up with the number 6? Number 3 copper. Anybody can size it with the other than calculator? One more time. Clear, clear, clear. I have 91 amps, and if you go to the amp, and if you go to the wire size, I have 3 copper. Okay, so this number here is going to be 3 copper. Oops, which one are we here? Number right here, right? Number 3 copper. Oh. The 75. 60. I bet you from a 60-degree column. If it's mechanical equipment like this, guys, even if the amp is lower than 100, 99.9% the lugs are rated for 75. I'm telling you, you go to 75. If it's mechanical equipment like these 3-phase. Any question about, so I went to 75-degree and size it. Okay, let's see how conduit. I need a conduit. I have 3 conductors because it's only 3-phase, right? I need 3 conductors. So I have, let's clear this one. I have 3, number 3, wire size number 3, 3 conductors, THH, what did you use again? THHW, yeah? And I need a conduit size. I have 1 inch EMT, but I need, I don't need EMT, I need PVC schedule 80. Let's use schedule 80. What was the multiplier for schedule 80? Flexible metallic rigid schedule 9. So if you go 9, set conduit, they'll get you 1 inch and a quarter. What did you come up with? 1 inch and a quarter. So an inch and a quarter. Please review my calculation here. An inch and a quarter. So I came up an inch and a half. An inch and a quarter. Inch 0.25. Okay. All right. So, and please review it based on the code. Then, now panel feeding it. Any question about sizing the conductors, guys? You're going to size a conduit feeder that's feeding this. Then you're going to go to the panel. This is fed from the main panel. How do you know if it's fed from everything? The mechanical equipment are fed from the main panel, right? Okay, how would I know? All of them, which panel are going to be fed from? You can circuit them. There's a few of them are going to be from the main panel. The rest of them are going to be from the receptacle panel. So, air handling unit, condensing unit, boiler pump 2. All these are going to be from the mechanical panel. Why? Because Chad is telling you this on page 11. The 2 pumps and the 2 chillers, only from the mechanical panel. Everything else is what? Receptacle panel. Okay, so let's go. Now, I trust that this is what your numbers, guys. 798, okay? Then, overcome protection device. Do you guys remember the sheet, what the sheet says for the overcome protection device for this one? It was 110. The manufacturer are telling us it's 110. If you guys go to page 18, under maximum fuse size, 110. So I'm going to go size it 110. Size this one 110 for them. They're saying 110 fuse, but I don't have a fuse panel though. So what I'm going to end up doing, I will put 110 amp circuit breaker here and move all the way right next to Ashley, put my disconnect here. The disconnect will have 110 amp fuse and feeder machine. That's what we're doing. Because they say the fuse, and I can't put a fuse in a panel that has circuit breakers. How are you going to do that? So, long story short, you end up sizing 110 with 110 amp circuit breaker to protect your feeder. Right next to the equipment, you throw a fuse disconnect, and the fuse will be 110. As far as you're concerned, it's going to be 110. Okay. Any other notes? You add it here. All right. So I went through one of them. Anything else? Any other one that's well? Yes, sir. If you don't know, all the panels that we have is going to have receptacles very similar to this. These type are called inverse type circuit breaker. All of them. All the receptacles, all the circuit breakers are going to be inverse type circuit breakers. Period. So that one that you're looking at right here, it's going to be inverse type circuit breaker. Period. All of them are inverse. Yes, sir. You can, but you oversized. The reason why we have the overcome protection device much larger, Dustin, than the conductor is because of the inrush of the equipment. Mechanical equipment and motors have an inrush. That's why we always oversize the overcome protection device to handle the inrush. But I don't need, the cable does not need to be sized to handle the inrush. Cable, they can handle the inrush without oversizing them. So that's why you don't have to match. You're absolutely right. Almost always we match the overcome protection device to the cable, except if you're feeding mechanical equipment, motors, HVAC equipment, chillers, heaters, for example. In a heater, you almost match, the overcome protection device almost match 1.25, 1.25. But mechanical equipment that has a machine in it, motors, don't because of the inrush. Any questions about this? Yes, sir. Which one? What? Pump number one. Let's go do pump number one. Gotcha. Pump number one, right? This one? Pump number one, it's a 2 horsepower, right? 2 horsepower. The full load amp from the NDC code book is 7.5. Is that right? Do I have a second for that one? 2.5 okay. All right, here you go. Pump number one, 7.5. Okay, so everybody knows where we got the 7.5 from NEC code book 430.250. Okay, now let's look what they're asking us here. This is a disconnect. Do they need a disconnect? Let's look at the boiler located in the mechanical room, blah, blah, division 16 to provide combination starter / disconnect adjacent to the unit. Do they need a disconnect? Yes. Did they say fuse disconnect? No. A combination starter disconnect. So need a combination is anema. Start a disc. So I need a disconnect. Okay, take this. So a disconnect type by division 16, disconnect size. I'm not going to do it with my calculator, guys, but you take the one, what's the full load current? 7.5 multiplied by 1.75, right? So you take 7.5, multiply it by 1.15 equal, you have 8.625. The next standard disconnect is what? 30. So that's why you come up with the 30 here, right? So perfect, thank you. That's 30. And then you come over here. Did they say anything about fuse? No, so it's going to be non-fused. They need a disconnect, but non-fused. Where it's going to be located? Room 116, because they say so, right? And division 16, it says located in electrical mechanical room. So if the pump is located in the room 99% of the time, the disconnect will be right next to it. Make sure, right? So makes sense? All right, so that's a location. Let's go to, what's this one? This one is this is the starter by starter type. Okay, now we start. The starter by division 16, the starter size, it's going to be NEMA. Now, I want you guys to go from here. I want you to go to the NEMA, and this is how you size a NEMA. You're going to go to page 6-4. If you go to 6-4, page 6-4, and it's a 208 system, and I need, what is it, 2 horsepower. So what's the NEMA that give me 2 horsepower? Go all the way to the first column, the NEMA size, 0. So I need NEMA what? 0. Everybody got that one? Page 6-4, under 200 volt, 208. The first column, that will give you 3 horsepower, right? I need 2, so I can't go to 1.5 for small. So I have to go to 3 because 3 is bigger than 2, right? And then it's 0. Everybody knows why I get that one, so I'm going to go 0. So this is what I typed in, NEMA 0. Okay, that's it. All what you have to do. Type NEMA 0. Dustin, does it make sense? NEMA 0. Okay, so that's the type. So let's see. This is starter by starter size, NEMA 0. Now I'm going to go all the way to the starter type. Oops. Where was I, Chad? Okay. NEMA 0. Now zoom out, Chad. So starter type and location. So we know what the size is. NEMA 0. Starter type. I told you guys if it's a NEMA, it's FVNR. It stands for full voltage, non-reversible. That's the magnetic starter sitting on the wall right there. It's called full voltage, non-reversible. Means dumb magnetic starter. Just push the button, close, push the button, open. Okay? It's FVNR. Did you guys get that one? FV stands for full voltage, non-reversible. What's the alternative? Full voltage reversible. If you need to reverse the motor, they didn't tell us about anything about reverse. Okay? Where it's located, the type, where it's located, the size, starter size, it's going to be located in room 16 because the disconnect and the pump is in room 16. If you don't know where it's going to be located, it's always located where the equipment is located. Okay? Any question, guys, about the NEMA, these two, the NEMA size and the NEMA type? How does it make sense? It's always full voltage, non-reversible, unless they tell you they need to reverse the motor. Okay, so let's go back here. Division, I'm going to say division 15 here until we figure it out. Division 15 is providing the control, always the control, always the mechanical equipment control, guys, division 15 for the most by control type, Johnson, whatever. Leave this empty. Size the conductors. 3/4 inch EMT number 3 is more enough. More than, you don't want to pull any conductor smaller than number 12. So if your conductor is smaller than number 12, you're going to pull 12. So remember it was 7.5. What is it? 7.5. You multiply 7.5. 1.25 times 0.5, you're going to get 9.4 amps. I can pick this one with number 4 conductor, guys. Number 14. You don't want to use anything in commercial less than number 12. So you have 3 conductors, number 12. Why did he say 2 or 3 here? Are we okay? Where are we here? Hard to see the big picture when we're zooming. Okay, here we are, right here. Right here. Yep, it's 3 conductors. Why 3? Now, why THHN? Why THHW, guys? The equipment was in the room, right? It's a pump. So probably you could get away with, unless you're underground or outdoor, it's N. It's not going to change your system as. Probably if you look at the EMT, I could have gotten away with a 1/2 inch here. So, but 3/4 inch is not bad. A lot of people don't carry less than a 1/2 inch anyway. Less than 3/4 inch. Okay. Then you go to the mechanical room where it's fed. Oh, circuit breaker. Now this is a motor. Let's go do that one for circuit breaker, guys. Circuit breakers, take this. Here's my 2 horsepower motor, 2 horsepower. And the voltage, what was the voltage again? 208. The voltage 208. And here's the full load amp, 7.5, right? And I need the conductor wire size, set and wire size. It's telling you number 14, but we decided we're not going to use number 14, number 12. I need the inverse type circuit breaker. Can you guys see what it says inverse type circuit breaker? If you hit this, it gives you 18.75. If you hit it again, it will tell you what the multiplier is. Can you see the multiplier is? 250 from the code. It's an inverse type circuit breaker, 250%. So hit one, so hit, this is the table, this is the multiplier, 18.75. You go to the next standard, which is 20. So that's why my friend Dustin have gone to 20 here. 20. And what type? All inverse type circuit breaker. Any other component they want you guys to go over? Yes, sir.
How come we use 1.75 and before?
Okay. Very good point. Let me show. We did them with the chillers, right? Okay. Let me show you where we use them. Here's my NDC code book. Let's go back to the mother. To the source, right? Because we all go by the code. Let's go to the motors. If we go to the motors, Article 430, what am I here, Chad? Article 430. Okay, if you go to Article 430, let's go all the way to the overcome protection device. The table that says about the overcome protection, right here. No, not right here. It should lie to you. Okay, give me a second here. Right here. This is the table that you need right here. It's page, for you, it will be page 323. Are you guys there? 323. Now this applies for all motors. Your motor, guys, is single phase. You are most likely induction motor. If you're using non-time delay fuse, your multiplier 300. If it's dual time, 75, 99% in this project, we're going to be right here. Can you see it? 250. 99% of the time in this project, we're at 250. See why we came up with 250, guys? Right in here. For this project, 250. For all the motors, 250. I'm in squirrel cage other than design B energy code. 3-phase. Yeah.
Where did you get the table based on number 20?
Where did I get what?
The number 20 for the inverse breaker?
Oh, for the breaker. For the breaker, it was 7.5. What is it? 7.5 times 2.5 equal. What was it? 19 something. Then you go to the next standard, which is 20.
Where's that table?
Which table? You're going to go to table 240.6. You're going to go to 240.6 to find which standard. Okay, so Dustin, for this project we're here. All the motors are going to be sized based on this, except the chillers, because they're not motors, they're special type of motors. Okay, so every other motor is going to be sized based on 250 because we don't have fuse panel. We have a circuit breaker panel. We made the decision. Cool. Now let me show you. The mechanical equipment, the chiller that we just did. Come on, Chad. Okay, let's keep going, guys. Let's actually go to the mechanical equipment. Now the chiller, we've just sized them a second ago. Chiller, right here. This is the article that applies for mechanical equipment. Do you see that? Air conditioning and refrigeration equipment. That's a chiller. Not. They're motors, but they're special type of motors. They grab, because the chillers, guys, the chiller has a compressor and a motor compressor mechanism. They work in conjunction with each other. They size them slightly different than any other motor. So anything that has refrigeration, that has a compressor, you size it based on this article. Okay, so if you go here, you're going to go 240.22, I believe, 240.22, 22. Where am I here? Change it to 240.20. Okay, right here. Right here, tool, go size, mark, highlighter. Can you see that? This is application selection, rating or selecting for individual motors. It says the overcome detection device right in here. What I want you to pay attention to is this. It says a protective device having a rating or setting not exceeding 175% of the motor compressor rating load current or branch circuit selection current, whichever is greater, shall be permitted. Then they go, if it doesn't start, they have an exception where you can go to 225. So this is where we got the chiller. But the chiller, we actually didn't size it. It's already sized for us in the cut sheet. Had it not been sized in the cut sheet, then we go and we multiply it by 1.75. That makes sense. Times the rated load amps. Which is full load current. Yeah. They call them rated load amps. Okay? All right. I know you guys might need to swing here. Oops, I don't want. Any question? If you guys made any mistakes also when you do them, don't worry. I review this one with you one-on-one too. I mean, but in order to do this, Phil, you really need the information about the machine. If it doesn't say anything about starter, don't provide the starter. If it doesn't say anything about the disconnect, don't provide the disconnect. Meaning, the mechanical contractor will provide it. Any question? Yeah, for you? Yep, absolutely. I started Revit accidentally here. All right? Thank you, guys. I know I pushed you this Monday, especially when I wasn't here for a couple of days. Thank you.
The CD is not in yet. It's just a case. This is an empty case. I don't know.
Oh, the CD?
I don't know who has the CD.
Oh, the CD, I thought, yeah, it's here. Thank you. Yeah, thank you.